We'll start in about 4 or 5 minutes. I see people who haven't been here for a while. Today's the day for the review. We're reviewing today for a test on Monday. So don't anybody leave early. And the people who haven't been here for a while, this is the right day to come. Good, good. Okay, does it? The test should be from the 26th to the 27th. Did I make an error? The person who sent me the little message, did I make an error? The test should be from the 26th to the 27th. I'll check it when I leave here today, which means Monday to Tuesday. Yeah, on Moodle, what does it say? On Moodle, what does it say? It should be the 26th to the 27th. Did I make a mistake? Okay, I thought so. Good. So one more time, then we're reviewing at the end of today. Don't anybody leave early. And on Monday, the 26th, is a test on chapter 4 and 5 and 6. Be sure to take it on Monday or early Tuesday morning. I'm going to start in about 1 or 2 minutes. This is a pain in the neck taking attendance, but it has to be done. Okay, 1 more minute. We're going to start. Okay, so what we're going to do, we're going to spend about 20 minutes on chapter 7, which I want to finish up today. We're not doing 7 again. And then in about a quarter of, I'm going to begin with 15 minutes on chapter 4, 15 minutes on chapter 5, and 15 minutes on chapter 6 for a test on Monday the 26th. Monday the 26th, a test on chapter 4, 5, and 6. I'm not going to call out names, but a few of you people have been absent a few times. I'm glad you're here today. today's the right day to be here. Be sure to take that test. And the good news is that when you take that test, we'll be at the halfway point. So one-time test on Monday, the 26th, on chapter 4, 5, and 6. All right, I'm done with this junk now. Let me do what I got to do. So I'm going to minimize this as usual. Minimize this. Go over here. Recent items. Bingo, zingo. Bring this up. No, bring this up. Bring this up. Okay, we got about, I'm going to go through this one more time. Now, those people who missed it, pay close attention. This stuff will be on the Thanksgiving test. And I'm not going to do it ever again. So this is the last lecture on this. And some of you missed it, so be very careful. And I've only got about 20 minutes to fit this all in. Okay, this is my big day. This day I have to work very hard. You have to work hard on Monday. I have to work hard today. Okay, this is our famous 7 layers. This will be on the Thanksgiving test. Our famous 7 layers. Don't miss it. One more time. The OSI is the 7-layer model. The OSI is the 7-layer model. All right? I'm not going to bother with my stupid post office thing, but I'll just do the bottom of this, the bottom dot, where it says a layered approach reduces complexity and turns it into a sense of interconnected tasks. There'll be nothing on any test about the post office, so you can forget this part of it. I gave it once. If you missed it, you're not going to see it. So what? It won't be on any test. I don't have the time to get to it. Okay, there's our 7 layers, and we would have to know this for the so-called Thanksgiving test. By the way, there's a test Monday, and there's another test in the middle of November, just before Thanksgiving on a Monday, and that will be on this stuff. So application, presentation, session, transport, etc. Now let's go to the next slide. Each layer has its own set of well-defined functions. Each layer communicates with the layer above or below it. So what does it say here? The transport layer works with the network layer below it and the session layer above it. Let's see, is that really true? Let's verify. The transport layer works with the network layer below it and the session layer above it. Sure enough, it does, provided that you have the layers in order. So I'll give you the acronym later on. You're going to have to know those layers and in that order for the Thanksgiving test. Okay? Now, the stuff we're reviewing today, which will be very critical, is you have to know every one of these things here. Don't confuse DHCP, DNS, know what TCP is. That we're going to review in about 10 or 15 minutes, and we're going to need that for the test Monday. What we're saying is, it's how we beat it against these 7 layers. And this 7-layer stuff you're going to need for the Thanksgiving test. Okay? Anyone who absent and missed this last lecture, pay very close attention, because I'm not doing it again. Okay, peer communication. Each layer on one computer behaves as though we're communicating with the same layer in the other one. Now, this is a cuidado, so be very careful. Watch carefully. My application layer talks to your application layer. My session layer talks to your session layer. My transport layer talks to your transport layer. Oh, does that mean you have 7 or 8 wires? No. My network layer and your network layer are not directly connected, but they talk as if they were directly connected. My session layer and your session layer are not directly connected, but they communicate as if they were. So here it is. Each layer on one computer behaves as though we're communicating with the same layer on another computer, behaves as though we're directly connected, even though it is not. And that's important. And you have to know the 7 layers in order. And on my computer, I've got 7 layers. On your computer, you've got 7 layers. And my layer talks to your layer, each one of these, looking like they have 7 wires, even though they don't have 7 wires. It's an imaginary connection. Okay, now here's the biggie, and this is slow down. Okay, Professor, I was absent for the last lecture. So I got all these numbers I got to know. Well, what are you trying to do here? Why do I need these layers? What are you trying to do? You're trying to make the packet or frame to send the data. So I want to send you some data. I send you the Excel spreadsheet or the Word document I put in the application layer. As I go down the 7 layers, what am I doing? I'm building a packet or frame. One more time. As I go down the 7 layers, I'm building a packet or frame. Here it is. On the way down to the protocol stack, some layers add their own formatting, which is called encapsulation. I go down and I build a packet or frame, making it encapsulated and making it wider and wider. Okay, lecture's over. Now, watch carefully. At the receiving side, I get the packet or frame, but I don't want that. What I want is the actual term paper that I sent. So I got to go up to 7 layers, strip away the extra crap to get the original data. So on the receiving side, I go up to 7 layers, strip the header information away, called de-encapsulation, and get the original data. So one more time, I'm sending you my term paper. I put that into my application layer. It goes down the 7 layers and creates a bunch of packets or frames that you get. You get the packets of frames. Very interesting. I got them. But I don't want any packets of frames. I want the term paper you sent. So I go up to 7 layers on the receiving side, called de-encapsulation, stripping it away, returning it back to the data that I sent. Why do I need the 7 layers? To build the packet or frame to send the data. On the receiving side, to receive the packet or frame to receive the data. No, going down the 7 layers is encapsulation, and going up to 7 layers is de-encapsulation. All this stuff is for the Thanksgiving test, which is only 2 or 3 weeks away.
First, I have a question. When you say either an IP address or a MAC ad or a packet or a frame, does it do it both at the same time or just one or the other? A packet or it does?
First, it becomes a packet with the IP address. Then when you add the MAC address, it becomes a frame. Just like in chapter 1 or 2. First, you make a packet. What is that? The IP address and the data. That's all it is. Wait, I want a frame. Fine, now add the MAC address and the error checking, and now you have a frame. All that is encapsulation. It becomes first one and then the other, just like in chapter 1, 2, and 3. Very brilliant question. Very brilliant question.
Thank you, Professor.
I know. All right, here it goes. And I'm not going to do this 40 times. I won't have time. I need the 7 layers. Now, big cuidado, we're starting with layer 7. We're not starting with layer 1. So that application layer, what's the top dot say? Interfaces with the application, communicates with, talks to the application. A lot of people mistakenly believe that the application runs at the application layer. No, the application runs on the computer, but the application layer communicates with or talks to the application, right? Layer 6, the presentation layer. Well, why is this layer 6? So I'm going 7, 6, 5, 4, 3, 2, 1. Second one down. Presentation layer, data formatting. How does the data look? How do you memorize what's the presentation layer? How do you present yourself? How do you look? How does the data appear? Data formatting, presentation layer, layer 6. Okay, session layer, layer 5. Now again, 7, 6, 5, 4, 3, 2, 1. This is the 5th layer up, but the 3rd layer down. Again, I want to talk to you. Initiates the session, session layer. I'm sick of talking to you. I want to hang up. I'm going to terminate the session, session layer. But here's my favorite one, the 4th dot down. Keep talking. Go a little faster. Go a little slower. Speed up. No, wait. Slow down. No, keep talking. But don't go faster. Go slower. All session layer. Manages the ongoing communication session. Initiates the session, terminates the session, and manages the ongoing session. Session layer. Layer 5. Remember the numbers also. Remember the numbers also. Now, here's the biggie. We're about to do a review in about 10 minutes. Layer 4 is the transport layer, but it's also where TCP operates. Now, remember what TCP was from chapter 5. TCP, connection oriented. What does TCP do? Flow control and acknowledgements. Remember the sliding window. Resequencing, 1 out of 10, 2 out of 10. SYNAC-ACK, all that's done by TCP. What does that do? Verifies delivery, connection oriented. Where is that? That transport layer, layer 4. So all the stuff that TCP does is at the transport layer, layer 4. What does it do? Verifies delivery, resequencing, flow control, SYNAC-ACK, all is at the transport layer, layer 4. All right? I'm going a little rapidly because most of you have seen this before, but about 4 or 5 of you were absent last time. You should be taking copious notes because I'm not doing this lecture again. Now, layer 3, we're going down, 76543. That to me is one of the more important layers. First of all, and the gentleman who asked the question before, I think it was Joel Lopez, that's the one that has the IP address. Well, if it has the IP address there, that's the one there, Joel, where it would just be a packet because it has an IP address only. And wait, what about a frame? Yeah, that's coming up. Here it's only a packet. It also performs the best path selection. Well, wait a minute, I thought the one that chose the best path was the router. Well, sure enough, the router operates at the network layer 3 because the router uses IP address and uses packets. So the best path is at this, the router is at this, and the IP address is this. That means, give me a drum roll, the internet operates at this layer, network layer, layer 3. The internet operates at this layer. The IP address is. And for the guy who asked me the question, here it is only a packet. Okay, we're done. Now wait a minute. When do I get to be a frame? Well, what do I do to make a packet into a frame? I have to frame it with the MAC address and the error checking at the end. So now, when I go down to layer 2, now I frame it. Why? Because I add the MAC address. The MAC address is at layer 2, the IP address is at layer 3. And I also add the error checking at the end. So it is now a frame because it has the MAC address at layer 2. Okay? And now it's a frame, and now we can send it. Now, you always say which is the most important layer, and the real answer is you can't omit any of them. So they have to have all 7 layers. You can't omit any. So finally, now we're really done, right? Well, not quite. And I'm not doing this a second time today. We won't have time. And the answer is, this is layer 1, which is the 7th layer down. Remember, we went 7, 6, 5, 4, 3, 2, 1. Let's get physical. If you can touch it, feel it, measure it, or cut yourself on it, it's at the physical layer. So the wires, the connectors, they're all there. But so are the actual signals. Plus 5 volts in ground, physical layer. Light on, light off, physical layer. Radio wave on, radio wave off, physical layer. Okay? That's the one that sends the actual ones and zeros in bits that you can measure. You might argue this is the most important layer because if you don't send the actual ones and zeros, nothing gets through. All right, so I'm not doing this again, but I'm going to slow down and show you something. So here it is. Oh, encoding is not encapsulation. Encoding is making the thing in physical ones and zeros. That is plus 5 volt in ground. Light on, light off. That's encoding, and that only happens at the physical layer. And that only happens at the physical layer. All right, so summary. Here we go. Application layer communicates with the application. Presentation layer, data representation, data formatting. How does the data look? How does the data appear? Session layer, initiate the session, terminate the session, and maintain the ongoing session. Transport layer, that's the TCP, reliable delivery, connection oriented, okay? Sequencing, acknowledgement, flow control, all done with TCP at the transport layer, layer 4. And here it is for Joel Lopez who asked the question. Network layer, it's a packet. Why? It only contains the IP address. Network layer, it's a packet, only contains the IP address. The router operates here. The best path is here. The internet operates here. So now Joel says, wait a minute, I want to turn it into a frame. Fine, you can turn it into a frame. The data link layer adds the MAC address. When I add the MAC address, what have I done? I've turned it into a frame. That's at the data link layer, layer 2. And finally, I turn it into actual ones and zeros that I'm going to send. That's the physical layer, layer 1. All right, most important thing, we're going to finish up in a minute, but we have to go all the way back. How do I remember the order of these layers? Let's remember them now. So it's application presentation session 765. So we have several acronyms, right? All people seem to need data processing. All people seem to need data processing. And try to remember too the numbers 7654321. You will be asked on my test about layer 5 or layer 2 or layer 3 by number and not necessarily by name. All people seem to need data processing. Okay? And know the number that goes with it and what goes on in each layer. For those who want to do it from the bottom up, people do not throw sausage pizza away. People do not throw sausage pizza away. Be sure you have the order of that for both my Thanksgiving test, and again, I'm not just busting your chops to be mean. If anybody here tries to take the Network Plus certification, you have to know the 7 layers. You have to know them cold. You have to know what number each one is and what each layer does. Okay, so it's very important that you memorize the 7 layers. What did I say when you're going to take the real test? You might want to write these down on a scrap paper. Now remember, when you're taking the Network Plus test, you can't bring any notes in, but they give you some blank scrap paper. Nothing would prevent you from writing this down on the scrap paper from memory, and you should be able to memorize it. Okay? So know both acronyms and be sure to know them in order, because you may be asked the exact order on my test. I'm not asking you to bust chops. You really do need to know the exact order and what each one does. Okay, I want to get through this because I'm pretty much done. I'm just going to do one more thing and then we're done. People who were absent last time, I'm sorry I'm not doing it 4 times, but the people who were not absent last time have seen this now multiple times. One more time, when I finish this, I'm never doing this lecture again, but in every lecture after this, we're going to refer to and use the 7 layers. So we'll never have a lecture on the 7 layers, but we'll use them from now on, and we have to know them. All right, let's finish up, and then we can do our review. The last thing is this stupid IEEE modification, okay? And that was the IEEE people came off and said, we don't like your 7 layers. We want to change it, okay? And so I'm skipping this crap, and it's here. So we want to change it. We don't like it. So they said, no, you can't. You can just modify it. So watch what happens. Everybody pay attention. Here's my 7 layers. This is the OSI 7-layer model. And yes, you have to know this for a test. Well, the IEEE said, we want to change all this. Well, screw you, you can't. What you will be allowed to do is you can simply modify this 1 layer here. So look what they did. They said you were expanding, separating the data link layer into 2 sublayers, the LLC and the MAC. One more time, the LLC and the MAC. So let's read them. So we took the data link layer, layer 2, and we said the LLC controls the data link communication, defines use of logical interface points used to communicate with the upper layers. I sort of understand that, I sort of don't. But the cuidado here is we're communicating with the upper layers, obviously, because that's what they communicate with. Fine, we got that. Next. The MAC layer manages access to the physical medium and communicates with the physical layer. Now, be careful, watch carefully. Let's look at this. The MAC layer communicates with the physical layer because, look, it's connected right next to it. The LLC communicates with the network layer because that's connected right next to it. Well, what did we say? Lopez, pay attention. We said the MAC address is at the data link layer, and the MAC address is at the data link layer, okay? And I just said yes to whatever you asked. All right, so, but what I'm going to do here is, okay, what was I saying? Okay, the MAC layer. So what's the MAC address? The MAC address is at the data link layer. Well, the MAC address is really in the MAC sublayer of the data link layer. One more time, the MAC address is really in the MAC sublayer of the data link layer. That's where it really is. Now, how am I going to get rid of this thing? I don't know how to do it. So I'm going to have to, yeah, I knew that would happen. All right, I can't. Okay, so there it is. So let's try it one more time. All right, here it is. So All the IEEE modification is we separate the data link layer into the LLC and the MAC layer. That's all we did. The LLC is the one above, the MAC sublayer is the one below. So two things. The MAC sublayer communicates with the physical layer, and the MAC sublayer is where the MAC address is. Well, wait a minute. Didn't you say the MAC address was in the data link layer? It is. It's in the MAC sublayer of the data link layer. That's all the IEEE certification is. So I want to stop. So I'm just going to on my Thanksgiving test, you want to know the 7 layers. You want to know the order of the 7 layers. You want to know the number that, presentation 6, session is 5. And then you want to know what every single layer does. And that would be on the Thanksgiving test. And we'll be doing a review for that sometime in November. Okay? And you would need to know that. I am never lecturing on the 7 layers again. However, every chapter from now on is going to use them. And something else. All the courses from now on, if you take my Cisco course, it begins with the 7 layers. Okay, so we're going to have to know that. All right, I think I'm done. I'm exhausted with this. You're never seeing this lecture again. People who are not absent have seen it twice. People who were absent only saw it once, but better late than never. I'm going to stop doing this, stop sharing. Okay, I just want to check okay, I got Anna came in and I got a few others. I'll mark them. I think I had everybody else. Sean came in. All right. So let me do 2 things. Let me mark the attendance of those 2 or 3 people. And now we're going to begin a review. One more time. This coming Monday is a test on chapter 4, chapter 5, and chapter 6. And we're going to do the review right now for it. Don't anybody leave. And the people who are making a guest appearance, this is the right day to be here. Okay, we're still missing some people, but I can't do much about it. Yeah, I'm still missing people, but I can't do much about it. All right, give me a second. I'm going to minimize this. I'm going to get rid of this completely. I'm going to go over here and bring this up. Okay, we're starting again with chapter 4, right? I've done this review for other classes, but not for you guys yet, so son of a bitch. All right, sorry. Okay, so we're going to spend about 15 minutes on chapter 4, about 15 minutes on chapter 5, and about 15 minutes on chapter 6. And be sure not to miss the test on Monday, which is Monday the 26th. Sorry about this. Good. Okay, so let's begin. Okay, several questions from this one. It's on page 145. We all know that EMI and RFI is interference. They're bad things. We don't like them. But the one we want to be very careful of is on page 145, the middle. What's crosstalk? Your conversations on this wire, your conversations on this wire. As long as they're far apart, no problem. If the 2 wires come together, the black conversation leaks over onto the blue wire, and the blue conversation leaks over onto the black wire. When they're in a bundle and close together, that's crosstalk. It's a bad thing. We don't like it, but that's what happens. Know what EMI is, know what RFI is, and know what crosstalk is, and understand they're a bad thing. We would prefer not to have them. Page 145. Okay, I think we're still on 145. Right down here. If the signal goes too far, here's 5 volts. But as it goes, it keeps getting lower and lower and lower, right? So as the signal shrinks, because it's losses, that's attenuation. Each cable can transport data only so far because the signals begin to weaken beyond what can be read by the receiving device. That's called attenuation. Attenuation is a bad thing. I can read with the light off. We don't like it. We don't want it. Know what attenuation is. Know what crosstalk is. Know what RFI and EMI is. And know what attenuation is. And I think that's all on page 145. Okay? I have to leave the light on so I can do this. And I'm watching my watch. We're in good shape. It's 3:45. I have about 10 minutes to get through this chapter alone, and then 15 minutes for each other chapter. I'm leaving all that out.
So, Professor, the first page is gonna be what's gonna be in the test, and then the second page, the attenuation, or also the encoding.
Okay. Everything I'm covering right now is stuff you should know for the test. This is Joel I'm talking to, right? So
Yes.
you said I studied this and I studied that and I studied the other thing. Study this stuff now and you'll pass the test. Don't study anything else. All right?
Okay.
So what I'm doing from now on is the review for the test.
Thank you.
Oh, good, good. See, oh, this one. This is important. This is page 150. We all know what twisted pair cable is. Twisted pair cable is this twisting pair, okay? Now, I'm not going to ask anything about Cat 6 and Cat 5. I should, but I'm just not. But one of the things you might want to know is this about the length of it. So, page 150. Twisted pair cable, the length is 100 meters. Now, what does that mean? It can be shorter than 100 meters, but it can't be longer. So, it could be 80 meters, 50 meters, 40 meters, but it can't be 110 meters. That's 100 meters, not 100 feet or 100 yards. So the maximum length of any kind of unshielded twisted pair is 100 meters. Know that for the test. I'm still in chapter 4. Okay, here's the good news. The structured cabling, remember we had a work area, the horizontal. Most of that you don't have to worry too much about. But there's one point there that's pretty important, and I'm going to skip ahead to it and show it to you here. And it's right here, and I think this would be page 156. Page 156. And that is when I finally got the Bergen network running, and I want to talk to you and you want to talk to me, we're all set. But at some point, somebody wants to go on the internet. Well, to go on the internet, I got to go off my network onto the big network, see? So somewhere in the building, there must be something called an entrance facility. So the entrance facility is a room in the building that says, where do I leave the local network and where do I go out into the main internet network? Well, in the entrance facility, there has to be a point called the demarcation point. It would be a metal plate on the wall. And that's the point where the corporate LAN equipment ends and the third party provider begins. Now, what does that mean in plain English? Everything this side of the demarcation point is the Bergen LAN, and Bergen technicians have to manage it. But everything the other side of that metal plate is Verizon or Sprint, and the Verizon or Sprint people have to manage it. See what I mean? So it's the point where the corporate LAN ends and the third party provider begins. The demarcation point is someplace in the entrance facility, and that's on page 156. Know that. Okay. We're still in this chapter, unfortunately. And the worst part is chapter 4. That's the chapter. 5 is the big chapter. Okay, fiber optic cable is a blinking light. Now, I'm not going to ask much about the coring and the cladding, but a fiber optic cable is a blinking light. It goes very fast and it's very secure and no interference. That's the fiber optic cable. And we talked about that, okay? And it only goes one way. But the problem with fiber optic is the cable length in fiber optic is extremely long. In other words, don't memorize this, but it's measured in miles. A copper cable is 100 meters. This is 2 miles, 5 miles, 10 miles. Super high speed, okay? Everything great about it. No interference. Super long distance. So, here's the big deal. What's the disadvantage to fiber optics? And this would be on page 167, I think. And that is, look at the top dot. Difficult and time consuming to install. Well, that makes it what? That makes it a lot more expensive. So if the cable costs more and the connectors cost more and it's more difficult and time consuming to install, that means what? Is the labor is going to cost more. So what's the main disadvantage to fiber optics? It's much more expensive because it's more difficult to install. Why don't we use it all the time? It's expensive. Is it the best? It's the very best. Why don't we all drive BMWs? Because we can't afford them. know that, but also know something else. And that is oh, I can't find where I want to point it out. But what I'm going to say is this. Well, here it is. Fiber optic is often used as a backbone cable and comes in bundles of 12. So in other words, what they're trying to do is the distance. It goes a long distance. So if I want to go between buildings, if I want to go for a long distance, I'd use fiber optic cable because the maximum cable length, 2 kilometers. That's a mile. 100 kilometers. That's 60 miles. So I can go between building to building with fiber optic cable, whereas I probably can't do that with copper cable unless the buildings are pretty close to each other. See what I'm getting at? Well, with fiber optic cable, if the buildings are thousands of meters away from each other, or even a mile or two away, I could run it because it wouldn't run out of distance. So fiber optic cable is good for connecting buildings or any kind of a long distance. Okay, now, here's my deal. And Joel Lopez, I'm talking to you. We're not done with the review, but I think I'm done with chapter 4 only. So I think I finished the review on chapter 4. So if you listen to all those things that I did, you will have chapter 4 down. And I believe that now we're going to go to chapter 5. And I want to warn you, I'm going to spend more time in that because there's a lot of stuff you have to learn. We'll still get out a little early, but I have to go to 5. Okay, so 1 down, 2 chapters to go. I'm trying to see if there's anything else I want to say in here that I have to know, and I don't think there is. Okay, so I'm going to stop sharing. Okay, I'm going to minimize this. Sorry about all this. There's no easy way to do it. Get rid of this. Go down here. Recent items. We're now going to start with chapter 5. There's chapter 5. Bring, son of a bitch, I keep doing the wrong thing. Bring this up, bring this up. Okay, here we go. And this is going to be the lengthiest part of the review, unfortunately. I'm just checking to see where I'm going. All right, let's go. I'll recognize that you're the last class I have to do this review for, so I'll know. Just quickly, we're going to review all of these. Remember what I said? I don't care about these 4 layers. What I care about is, of course, the 7 layers. But again, for Joel Lopez and others, the 7 layers will not be on tomorrow's, this coming test. The 7 layers will be on the November test. We're going to be reviewing almost every one of these right now, and that's what's going to take some time. Okay, let's start with this one. Try to remember that SMTP sends email and POP3 receives email. SMTP sends email, POP3 receives email. Now, I know what you're going to ask me, the smart people. You're going to say, do I need to know these port numbers? Well, for my test, no. But all of you smart people who think you might want to do the Network Plus certification, you would need it for that. So you are going to want to need the port numbers for the real certification, but you won't need them for my test. You would want to know that POP3 receives email and that SMTP sends email. Okay, but this one, unfortunately, you would want to know the port numbers too. Now let's go over this quickly, and this is important. This is page 195. What does FTP do? It transfers files. I want to send you a file. You want to send me a file. It's FTP. It's a sub-protocol of TCP/IP. And remember what we said. It uses port 21 and 20, not 20 and 21. You say, well, professor, it's the same thing. Why do I want to say it backwards? Because if I want to connect to you, I connect to you on port 21. So, hey, I want to talk to you. We're on port 21. I got some data to send you. You say, okay, send it to me. Well, wait, I can't. Well, why not? Because we're talking on 21. So I'm going to send you the data on port 20. So port 20 is the data port. On port 21 is the command and control port. The exact opposite of what the slide says. So one more time. Port 21 is the command and control port, even though the slide says differently. Port 20 is the data port, even though the slide says differently. What is FTP for? It's for sending and transferring files. File transfer protocol, transfer a file. Do I have to know that it's 21 and 20? Yes. Yes, you do. Okay. Anybody who doesn't believe me, by the way, is all welcome to look it up, but you'll find out that the book is wrong and I'm correct.
So it's backwards.
Right.
The 21 is the command and control, and the 20 is the data.
You got it. It's backwards because someone made a mistake when they wrote the slide. So it's the right way, but the slide was written incorrectly by a person who didn't catch the typo.
Thank
Professor?
you.
Yes, go.
So you want us to remember port numbers 21 and 20, correct? Not
Yes.
okay.
Grandma, the way you said it was very clever because if you memorize as 21 and 20, you're knowing that we connect up on 21 and send the data on 20. See what I mean? That's
Yes, sir.
It's a little trick for remembering.
But just to clarify, I know it says uses UDP port 69, but don't remember that. Just remember.
No, be careful. FTP uses 2021. TFTP is something different. TFTP uses 69. TFTP is a different version of this that doesn't have all the checks and balances of this, and that only uses port 69 because there's no control commands. So TFTP uses 69. FTP uses 21 and 20. They're not the same thing. They're not.
That was a big cuidado right there. Big cuidado.
You got it. You're smarter than you look. Very good. Okay. Now, again, this will not be on the test. I'll cover this in another chapter in more detail on other stuff, but this is not important. This won't be on the test either. Now, again, this will not be on my test coming up, but if you're anyone here sitting, getting ready to take the actual Net Plus certification, you would want to know all these port numbers. Okay, this is a very biggie. Don't confuse DHCP with other stuff. What does DHCP do? It does what? It gives you an address when you don't have one. So I need an IP address. I need to get one. What does it for you? DHCP does it. Well, listen here. Automatically assign an IP address when it's needed. And that's very important. Know that. Don't confuse that with DNS, which does something else, or ARP, which does something else. You need an address, you get one. That's DHCP. And when you're getting an address, the DHCP server must have what's called the scope. What does that mean? You can't just get an address out of random. You got to get the right address. Well, how does it know to give you only a 168.14.12 address and not give you a 142.13 address, which would be wrong? Someone has to tell the DHCP server, here's the range of addresses you're allowed to give out. The range of addresses that the DHCP server is allowed to give out, that's the scope of addresses. And that way it always gives out the correct one. And no, this didn't make it to the test. And neither, oh, but this did, and this is all on page 198. This is critically important. 198, listen up. There's only one way to get a DHCP address. I've got to go through this DORA process, the rigmarole to ask. It's called the DHCP Discover. But notice the female name. Discover, offer, request, acknowledge. The female name Dora. Discover, offer, request, acknowledge. So watch carefully. I need help. Can somebody give me an address? That's a DHCP Discover. Yes, I can give you an address. That's a DHCP offer. I accept that. I want the address. I accept your offer. That's a DHCP request. Here's the address and everything you need. That's a DHCP acknowledge. So the discover, offer, request, acknowledge is the DHCP discover process. It's how a computer that doesn't have an address gets the address by a DHCP discover, offer, request, acknowledge, and know the exact order. The female name acronym DORA. D-O-R-A. Know that. By the way, as I told you, this has been this way for 20 or 30 or 40 years, so you might want to know it. It's been longer. This has been going on longer than some of you have been born. Right? Know that. I told you I'm going to spend a little time on this, so we had to do it. Now, DNS is not DHCP. Know what DNS does. What does DNS does? The top dot, name to address resolution. I have an internet name. I need the corresponding address. I'm not giving them the address. They already have one. I just don't know what it is. This name has an address. I wish I knew what it was. DNS resolves it or gives it to me. What's the proper address for Cengage.com? That's DNS. Okay, what's the proper address for Cengage.com? That would be DNS. A fully qualified domain name is simply what we would call an internet name. So a fully qualified domain name is www.bergen.edu or www.microsoft.com. That's all it is. Okay? The .com is the top level domain. The second level domain is the Bergen or the Microsoft. And the www is the computer name. One more time. Top level domain. .com, .org, .edu. Second level domain. Bergen or Microsoft. Host level is the www. That's the name of the computer. And that computer is the World Wide Web computer. Try and remember what got onto the thing. We're not going to have to worry about all the details of how it works. The resolver and the cache and that we're not going to worry about. Just know that you're resolving a name to an IP address. Okay, now this is the toughest part of it, and pay attention. If anybody's asleep, splash some cold water on your face and wake up. Okay? All right, let's begin. TCP, connection oriented. What does that mean? It verifies delivery of the packet. TCP, connection oriented. What does that mean? It verifies that the packet got there. Okay? IP is not. IP just sends it. TCP checks on it. Now, how does it do it? It does it through three things. It establishes a connection, it segments, and it ensures flow control. Big cuidado, Mr. Joe Lopez. All three of these are on the test. All three of these are on the test. I'm about to do a slide on every one of them. This is page 211 and 212. Page 211 and 212. Let's begin. How do I establish a connection? I establish a connection with the so-called TCP handshake. That's the famous SYN-ACK act. So watch carefully. I want to synchronize with you. I acknowledge that, and I want to synchronize with you. I acknowledge that. So one more time. I want to synchronize with you. I send back, I acknowledge that fact, and I also want to synchronize with you. And then I send back, and I acknowledge that fact. That three-way handshake is how I establish the connection. Understand that TCP establishes a connection with a three-way handshake. It's called SYN-ACK act. I want to synchronize, I acknowledge I want to synchronize, and I acknowledge that. That's the three-way handshake. Know what the SYN-ACK does. Understand that. Joel, pay attention. Now the next one. It segments large chunks of data. How does it do that? Here it is. I break it up into segments, and Ethernet would be 15, 18 bytes. But here's the cuidado. Each segment's labeled with a sequence number. This is 1 out of 10. This is 2 out of 10. This is 3 out of 10. Now, why bother? Because when you receive the frames of packets, they'll be in the wrong order. You got packet 9, then 12, then 14, then 8. Who puts it in the right order? TCP at the receiving side puts it in the right order based on the sequence number. So TCP at the sending side gives each packet a sequence number. TCP on the receiving side reorganizes the packets based on the sequence number. That's how it sequences and segments the data. And that's the second one there. How does it ensure flow control with acknowledgments? Here it is. I acknowledge every packet. Well, if I acknowledge every packet, that becomes a problem because I got to send one acknowledgement, one acknowledgement. So instead, I create a window of packets. Look, instead of acknowledging every packet, can I acknowledge every 8 packets? Okay, I'll let you do that. How about letting me acknowledge every 12 packets? Okay, I'll let you do that. How about every 15 or 20 packets? Okay, I'll do that. That means I can send 8 packets and then I say I got them. 8 more and then I got them. Okay, we're changing it. Now you can send 12. Okay, I got them. 12. Okay, I got them. Sliding window. I acknowledge a group of packets, not one at a time. That's how I verify the packets got there. Let me go back. TCP reliability. First, it establishes a connection with the SYNAC Act. Know that for my test. Then it segments. 1 out of 10, 2 out of 10, 3 out of 10. Know that for my test. Then it ensures flow control with acknowledgement with the window. I acknowledge a sequence of packets. Know that for my test. What does all of that? TCP. Why does TCP do that? So it will become connection oriented. Connection oriented meaning verifying delivery of the packets and making sure they got to. All of that is 211, 209, 211, and 212. Know all
Let's
of
just
that for
get
my
some
test.
information first.
Okay.
Finally.
I think we're done with that. It's called a segment. It's TCP uses something called a segment. On page 211, TCP uses something called a segment because for Joe Lopez, when it gets to the next layer, it becomes a packet, then a frame. So a
Once upon a
TCP is a
time,
segment, then it becomes a packet, then it becomes a frame at the other layers. Okay, now that is all on the test, so be sure to know that. I think we're just about done though with this chapter, but it's not that easy because, yeah, I think we got that. Yeah. All right. I'm watching 407. We have enough time. Oh, okay. Yes. Now, I'm not worried about IPv6 IP. Well, I am, but I'm going to do this stuff next chapter, which is coming up. The only one I want to do here is what is ARP, A-R-P, Address Resolution Protocol. And I believe that's on the test, and this is important. And what does it do? The top dot resolves an IP to a MAC address, changes the IP address to the MAC address. Now be careful, it doesn't change anything. You've got an IP address. You've also got a corresponding MAC address, but I don't know what that is. So if I go to your IP address, could I find out what your corresponding MAC address is? That's what ARP does. I know your IP address. You have a MAC address. I just don't know it. I need to find out what your MAC address is that goes with this IP address. That's what ARP does. Big cuidado, it doesn't do it the other way around. It doesn't resolve the MAC to the IP, only the IP to the MAC.
So it just transformed the IP to a MAC address.
Okay. It translates or resolves it because you already have the MAC address, you just don't know what it is. You're Joe, you have an IP address. You're Joe, you also have a MAC address. I'm Gary, I know your IP address. I don't know your MAC address. Finding out Joel's MAC address from Joel's IP address, that's what ARP is. Okay?
Thank you.
Good. All right, now here's the good news or the bad news. I think I'm done with this chapter. Now, here's the good news, very good news. The chapter 6, I don't have many items. There's like 8 or 10 of them, but each one is a mother. Each one is difficult. So we're almost there. This is tiring for me too, but I'm glad you're here. We're not doing this ever again. Okay, I got to minimize this. I got to get rid of this. Now I've got to go back over here. I've got to go to recent items. I got to go to chapter 6, bring it up. Okay, now I got to bring this up. Now I got to bring this up. Now I got to bring this up. Okay, here we are. Now we're in chapter 6. I think I have this down, yeah. I should be right. Okay, TCP/IP is 32 bits, 32-bit binary number expressed in dotted decimal. So let's, you can use this slide, but here it is. This is the 8 bits, it represents 192. This is the 8 bits, it represents 168. This is the 8 bits, it represents 14. And this is the 8 bits, it represents 250. Okay, so that's that. That is 32 bits. Subnet mask. 255 is all ones. 255 is all ones. 255 is all ones. 0 is all zeros. What this means is the number under the ones has to be the same. So you say, okay, 192. 192 isn't all ones. 192 is this number. But 192 is under this 255. We all got to be 192. 168 is really this number. But 168 is under all ones. We all got to be 168. 14 is this number. But 14 is under all ones. We all got to be 14. But here's the cuidado. 250 is this number. But 250 is under the zeros. So if you're 250, you could be 248, you could be 247. We've all got to be 192, 168, 14. But the second number, the last number, can be anything you want to, because we have to be on different numbers. So that's the subnet mask and the actual network. Now I may have to get my little. I wasn't prepared for this, but we have plenty of time. I may have to get my little marker here to write down. Okay, because this is what I want to do. So remember that the class A was what it was and the class B, and I know I got some people who don't understand this, so it's a problem. This guy is 255000. And what does that mean? The first octet, that's the only one. So 10. No, I have to do this. I'm sorry, I just have to do this. You won't be able to do it unless I forgot I was doing this lecture. Okay, so class A, 10.x.x.x. What's the subnet mask? We all have to be 10. Class B, 132.14.x.x. What's the subnet mask? Just two 255s. So what does that mean? We all have to be 132.14. You see the difference? This is 25500. This is this. You see the difference, right? And the class C, I hate to. Okay, no way to do this. I have to. And here's your class C. No, I did it wrong. Here's the class C. So that subnet mask is 3 255s. See what I mean? So there's your class A, your class B, and your class C. Now, we still need to know the CIDR notation. So what's the CIDR notation? Now watch carefully. I have to keep doing this again. This is a pain in the neck. I'm learning how to use this. I go back to a classroom. So if I do 10.x.x.8, that's the same as this. Why is .8? Because there's 8 ones here. So if I do 132.14.x.x/16, /16, there's 8 ones here and there's 8 ones here. So /16 is 2 255, /8 is 1 255. You see the difference? And by the way, all that stuff would be on the test. And the big cuidado. So here we go. So if I do this and I write /24, okay? Why? 8, 8, 8. What's 3 times 8? 24. So /24 is 3 255s, okay? /8 is 1 255, and /16 is 2 255s. Everybody realize that this 255 represents 8 ones. This 255 represents 8 ones, and so does this. What's 8 plus 8? That's your 16. And by the way, No one's going to ask you to get from here to here. That's too easy. What they're going to say, if you have a /16, what's the subnet mask? If you have an 8, what's the subnet mask? If you have a /24, what's the subnet mask? That's what you have to know on both the real test and on my test. Does everybody see that? We're in good shape, but we're going to go right to 4:30. Joe Lopez, that will be on the test. All right, let's keep, and I hear no questions, but I'd be willing to answer one if you had one. I'm going to keep going. None of this is on the test. None of this is on the test. And this is the CIDR notation. I'll just do it here. We just did it. But see, /24 is 3 255s. /16 is 2 255s. /8 is 1 255. This custom subnetting, I'm just going to say it one more time. We're going to get a mother-sticking lecture on this just before Christmas. It won't be on the final exam. It's very hard, but I expect you all to be here to listen to it, to see how brilliant I am. And for the 2 or 3 or 4 really smart students in the class, you would need this to get your certification. So we're going to cover this in December, and it won't be on this test. Okay, now we have to get to some very tricky stuff. Okay, let's do this quickly. I'm just going to go over the, where's my piece of paper? Oh, here it is. Here it is. I'm still going to have to write, I think. Oh, yes, there's one more thing. Okay, I need these commands. So let's do these commands quickly, but some will be on the test. Let's begin them. ipconfig is simply what is my IP address? ipconfig, what is my IP address? If I do the /all, it's what is my IP address and what is my MAC address. Not what is your IP address, what is my IP address? ipconfig, what is my IP address? What's my subnet mask? ipconfig /all, what is my IP address, subnet mask, and what's my MAC address? Mine, not yours. Command, that's a command. Ping, ping is used to test connectivity. Are you there? Now it says that ping does use the ICMP echo request and reply. It does that, but it says, am I in contact with you? What does ping do? It's a command to test connectivity. Can I see you? Are you in contact with me? Yes or no? That's important. But ping just says, are you there? Yes or no? And I say, well, wait, I'd like to know the path I took because I pinged you in California. Hey, I can't help you. Well, is there something that can help me? And here it is. Traceroute. Traceroute is the actual path it took. Traceroute says, are you there? Yes or no? And show me every router you went through to get there. Traceroute is I call ping with details or ping with steroids. Show me the actual path you took. That's what traceroute does. Trace the actual route. From, I'd say traceroute, www. something or traceroute 192.14. It would say, yes, I can see you, and here's every a router you went through to get there.
So it tracks your steps, all the steps.
Well, you say the steps. I'd say the actual path it took. Every router it went through to get from here to California, it will show you. So you say steps. I'd say actual path it took, all the details. Ping just says, yes, you got to California. Well, how did I get there? Hey, none of your business. All I'm telling you is you can get there. Traceroute says, yes, you got there, and here's the path you took. And NS lookup simply gives you an address. Now, here's what we said. I thought DNS gave you an address. Well, DNS gives you the address and takes you to the address. NS lookup gives you the address, but doesn't take you there. So what does it do? It takes a fully qualified domain name, gives you the address, but doesn't take you to the address. It's a command line version of DNS. It's a command line version of DNS. Now, I've covered most of what I have to cover, but there's one more thing that's very tricky. And I'm going to go back, and there's no way I can do this. No, none of this made it to the test, so we can skip it. Oh, one more thing did. And that is, I think, no, I don't think it did make it. Screw that. Let's just go back. So watch carefully. We're almost done. We're going to go home in a minute. I'm going to do some drawing. And what I'm going to draw is here, binary. Okay, so let's begin. I'm going to talk hexadecimal. Now watch, hexadecimal. 8, 9, 10. A, B, C. Now, if 8 is 8 and 9 is 9, is 10, I'm sorry. No, I did it wrong. It's 8, 9, A, B, C. So if it's 8, 9, then A has to be 10, and B has to be 11, and C has to be 12. That means D has to be 13, E has to be 14, and then we're going to get a trick here, and F has to be 15. Now be careful. Well, what about GHI? Well, there is no GHI. So it's 8, 9, A, B, C, D, E, F, G. You have to know that 8 is 10. Now, you have to memorize it. A is 10, B is 11, C is 12. No, you don't have to memorize it. If it's 8, 9, and A is the next digit, then A must be 10, B must be 11, C must be 12, D must be 13. See what I'm saying? Now watch carefully. Let's do some binary. This is 001. Why is that binary 1? There's a 1 in the ones column. Why is 010 binary 2? Because there's a 1 in the twos column. And why is 011 binary 3? Because 2 and 1 is 3. Now watch carefully. Suppose I put a 1 here, a 1 here, and a 1 here, and a 1 here. What is 8 plus 4 plus 2 plus 1? 8 plus 4 plus 2 plus 1 is actually 15. But 15 is F. So if you remember how the broadcast address was FFFFF, because F is binary 15, I'm sorry, F is hexadecimal 15, and hexadecimal 15 in binary is 8 plus 4 plus 2 plus 1. So, one more time. If it's a decimal system, it's 8, 9, 10, 11, 12. If it's hexadecimal, it's 7, 8, A, B, C, D, E, F. There's no GHI, it doesn't go any higher. And therefore, F is binary 15, and so F is all ones. And that's why the broadcast address is all ones. There won't be any real questions on binary numbers on my test, but knowing that 15 is F and that F is all ones is kind of important because that's where we got the broadcast address from. Do I have to know that A is 10, B is 11, C is 12, D is 13? Yes. Oh, how do I memorize that? You don't memorize it. 8, 9, A, B, C, D, E, F, G. If 9, what comes after 9? 10. What comes after 10? 11. What comes after 11? 12. You shouldn't have to memorize it. Do you need to know this stuff for my test here? Yes, you do. Do you need to know this stuff here for my test? Yes, you do. Okay.
Professor,
Go ahead. Go. What's your question?
when you mentioned they're all ones, it means it has like 15 times one, so it's like 1, 1, 1, 1, 1, 1 until it reaches 15.
Well, no. If I had all ones here, if I had all ones from here over, I'd have 128 plus 64. What is 8 plus 4 plus 2 plus 1? 8 and 4 is 12. Plus 2 is 14. Plus 1 is 15. That's why. What would 3 ones be? 3 ones would be 4 plus 2 plus 1. 3 ones would be 7. Matter of fact, as long as Joel's so smart and asking all these questions, Joel, you're a genius. Okay, so
Thank you.
you're right, Joel, you're a genius. Supposing I did this. Supposing I put a 1 here, a 1 here, a 1 here. That is equal to 7. Why? 1 plus 2 plus 4 plus 8 is 7. Now, 1 here, 1 here, 1 here, that's that. Now, what if I put a 1 here, and a 1 here, and a 1 here, and a 1 here, and a 1 here? That would be 15 plus 16. That would be, I think, 31. Why is that 31? Because 16 plus 8 plus 4 plus 2 plus 1 is 31. You know what I'm saying? So whatever there's a 1 in the ones column. Why is 1015? 101 is 5 because 4 plus 1 is 5. Why is 1106? 110 is 6 because 4 plus 2 is 6. Why is 1117? Because 4 plus 2 plus 1 is 7. Why is this 15? Because 8 plus 4 plus 2 plus 1 is 15. Right? Everybody sees that. The only reason 15 is important is because it becomes the broadcast address. That's the only reason. But yes, you would have to know this. And a lot of people say, well, I could never memorize this. Well, what are you memorizing? It's 8, 9. A has got to be 10. B has got to be 11. C has got to be 12. What are you memorizing? See what I mean? You got to know it. Okay.
Professor,
Yeah, go.
what page is that on?
Oh, I think that's 269 in that range.
Okay, thank you.
268, 269. Yeah, I think so. Okay. And again, be sure to know the /8, /16, and /24. Okay, be sure to know that. So this is a little bit trickier test, but I wouldn't say it's super hard. I would just say there's some little tricks in it. Okay. Again, I'm done now. Know this and know this. Okay. All right. I think I'm really done. I'm going to do what I always do. I'll stop sharing. Anybody who wants to stay can ask me questions, but I think I'm done. You can go home if you want to, but I'll stay for questions for anybody who wants. Oh, here's how I stay. Okay. All right. I'll stick around for questions. Don't forget, Monday is the test. Monday from noon to noon, you're taking a test on chapter 4, 5, and 6. Be sure to take the test.
Thank you so much, Professor. Have a good one.
Joel Lopez. This time, Joel, study the right stuff.